Greetings, welcome to Self-Assessment 5, Problem 1. So in this problem, they're going to ask us to fill in this table talking about these exponential functions. So our exponential functions that we have are f of x equal to 24 times 1.32 raised to the x, f of x equals 3,324 times 0.92 to the x, and then finally we've got f of x equals 1.04 raised to the x. So let's go through these each one at a time. Now, first question is they want to know one or two things. Is it growth or is it decay? And we recognize by looking at the base of the exponential function, we can tell whether it's growth or it's decay. So in the case of our first function here, we see that the base is larger than 1, and we know that growth is where b is greater than 1, and we know decay is when b is between 0 and 1. So equal sign, greater than, less than sign there. So we know in this particular case on the first one that this is going to be greater than 1, so this is a growth function. Okay, taking a look at the second f of x, we see that in this case we've got a base that here, this value 0.92, that is less than 1, and since that is less than 1, that's going to be a decay function. And last but not least, the third one is larger than 1, not by much, but nonetheless it is larger than 1, so indeed that is also a growth function. Okay, so the vertical intercept, what they want to know is where is this function crossing the y-axis. Remember that the y-intercept or the vertical intercept are the same thing. So when you see vertical intercept, one good way to think about it, in fact that's an excellent way to think about it, is that's where x is equal to 0. And so what they're really asking you to find out, or what they want to know, is what does f of 0 equal to? So if you know what f of 0 is equal to, you're going to know what the vertical intercept is. Well, one other thing that we need to remember is that if you take any value and raise it to the 0 power, you get back 1, with the exception of the base being 0, then that's going to be undefined. So what that tells us is in all of our cases here, all we have to do is look at the leading coefficient, which is many times known as the initial condition or the initial amount, and that will tell us our vertical intercept. So in the first case here, it's going to be at 0 by 24. Be sure and put these in as ordered pairs because intercepts are ordered pairs. In the second case, it's going to be 0 by 3,324. And last but not least, recognize that there is an unwritten 1 right there, and so that intercept is at 0, 1. Okay, cool. Horizontal intercept. Well, all of these are stock exponential functions. They have not been translated. We have not been shift up, down, left, or right, and so therefore they all will not have a horizontal intercept. In other words, it does not exist. And we'll see that again, that really that this question and the horizontal asymptote are kind of kissing cousins, and we'll talk about that when we get down there, okay? So we do not cross the x-axis, basically. But just as an aside, horizontal intercept, what that is telling you is that the y value is equal to 0, and none of these ever get to 0. Okay. Domain, since these are all exponential functions, all exponential functions have the same domain to them. It's from positive infinity to negative infinity, or you can use the fancy script R for all reals. Whatever way makes your toupee do the tango is fine with me. Okay, the range. Well, since all of these, again, are stock exponential functions, they have not been translated, then the range is going to go from 0 to positive infinity. And the endpoint is not included here. We don't get to start on the x-axis because we're never going to touch it. Which leads us to the last but not least one, the horizontal asymptote. Well, the horizontal asymptote is the x-axis. So if we kind of hack out a cheesy coordinate system here and we put in just a model exponential function, let's go ahead and put a decay one in here just to see what's going on. We know what's going to happen is the decay function is going to come down and it's going to get as close as you ever would want it to the x-axis, but it's never going to touch it. So the h asymptote is the x-axis. So what they're asking us for here, when they ask us for the horizontal asymptote, they're asking us for the equation of the x-axis. And so the equation of the x-axis is given by y is equal to 0. So in other words, that red line over there that I just did with the dash is the x-axis, and it's y equals to 0, and it's the same for all of them, because they're all stalkers in the sense that they have not been translated up, down, left, or right. They've just got different bases and different initial conditions. Okay, so that takes care of everything for this problem. We'll see you back here for problem number 2.